Today we are simplifying rational expressions. That's just these fractions here. And in all of these examples, we have stuff on top and bottom, and we're going to be able to simplify, reduce, cancel, whatever that looks like for that problem. We're going to start off nice and easy with these first two problems. These are called monomials because they are just a singular term, monomial as in mono, which is one term. Let's see, we have 15x cubed, y to the 5th, over 3xy to the 5th. So we're going to simplify this. Let's start with just the numbers, 15 and 3. This is where our calculators are going to come in handy. So 15 over 3, you can either use your calculator, simplify that, but 15 over 3, 15 divided by 3, that's a nice number. It's just 5. And before I cancel, I'm going to do this throughout the whole notes, and it might get a bit annoying. I apologize. But just to keep my notes looking nice, I'm going to rewrite it before I start canceling things out because it's going to look not so nice. So let's rewrite the problem first. 15x cubed, y to the 5th, over 3xy to the 5th. Now I'm going to simplify. 15 over 3, as I said, that's just 5. So the 15 is going to turn into a 5. And then the 3, it technically turns into a 1, but I'm not going to write a 1 there. I can if I want to, but I'm not going to. Let me see if the calculator shows it. I hope it does. So if we use the calculator, remember this is a fraction, so we'll use the ABC button. 15 ABC3, it will probably just give me 5. Okay, so let me grab my Post-its to kind of show you where that 1 comes from. So if we look at 15 over 3, I'm dividing this, but also I am reducing, if you will. So if I reduce the top and bottom by 3, I'll divide both of these by 3. 15 divided by 3 is 5, and then 3 divided by 3 is just 1. And then we know 5 over 1 is the same thing as just 5. So that's where the 1's coming from. Since we have more stuff in the fraction, we acknowledge the 1 is there. Otherwise, I wouldn't. Does that help? Yeah? Good. All right, so I'm going to write what I have so far. This is now a 5. 5x cubed, y to the 5th. On the bottom, again, I could write this one here if I wanted to. That's up to you, but since I have other stuff, I'm not going to write it. X, y to the 5th. Next, we deal with the letters. We've done this in previous units. When we divide the same letter, what do we do with their exponents? Subtract, exactly. So I'm going to acknowledge that this x has a 1 on it. There's no exponent, we know it's 1. And then I'm going to do the subtraction in the next step. So I'm going to write that out again. Again, this is just for notes to make it look nice. On your own paper, I know you'll do less steps, and that's fine. So the x's, we have x cubed and x to the 1st. We're going to subtract the exponents. The rule for this is you subtract where the larger number is. So the larger number 3 is on top, so I'll subtract up here. So I'm going to do 3 minus 1. And since I'm accounting for that up here, I can completely get rid of that bottom term now. It's gone. Now let's look at the y's. We have y to the 5th and y to the 5th. They have the same exponent. So if I subtract 5 minus 5, that's 0. The y will disappear. So since I have the same number on top and bottom, you can just completely cancel those out. Same thing, top and bottom, it's just gone. Just make it easier. When you're doing this, especially when we get into more complicated problems, you're just going to want to make sure that you're neat in your approach, kind of like I am here. If you get too scribbly, go a little too fast, then it's going to be kind of hard to keep track of what's still there and what's not. So just approach that carefully. So we still have a 5. We have x, and then my new exponent, 3 minus 1, is 2. And everything else is gone. Since the bottom of the fraction is completely gone, I don't need a fraction anymore. It can just be whatever was on top. 5x squared is my answer here. And there you have it. Questions on number 1? Okay, moving right along, number 2. Similar thing, there's going to be an extra step in this one. 24a squared b squared over 2ab to the 4th power. We got to handle this on the bottom first. 2ab to the 4th power. So I'm going to drop down and give myself a little bit of workspace. Reminder, when you have an exponent, that's how many times you're going to multiply it by itself. So I'm going to write 2ab out 4 times. That's how many times you have to write it. And this is multiplication. So we have 2ab times 2ab times 2ab times 2ab. It's a little tedious, I know, but the math here is not going to be hard. So let's do the numbers first. We have 2 times 2 times 2 times 2. So let's break that down. 2 times 2 is 4, times 2 is 8, times 2 is 16. You can also use your calculator for that. So we have 16 so far. And I just do this one thing at a time. So I did the 2's, now I'm going to do the a's. All of these a's have an exponent of 1. And when we multiply the a's, we're adding the exponents. So we have 4 of them. This becomes a to the 4th. All the b's have 1's as well, so it's going to look the same. It's also going to be b to the 4th. So now, on the bottom of the fraction, I'm going to replace that 2ab to the 4th with 16a to the 4th, b to the 4th. And then the top is the same as it was before, 24a squared, b squared. Before I mess it up, I'm going to write it out again. 24a squared, b squared, 16a to the 4th, b to the 4th. Now I can simplify that like I did in the first problem. We have numbers, let's start there. 24 over 16. And this is where I'm going to have the calculator help me out a bit. Remember that ABC button, that reduces fractions for you. 24 ABC 16. Since this is improper, the 24 is on top, it's bigger. This is going to be a mixed number the first time I hit the equal sign. So on this calculator, to fix it, you're going to hit second ABC, and that will change it to the improper form where it's just a number over a number. If you have the white calculator, it's basically the same. So I'll show you again just for review. 24 ABC 16. Tilt that so you can see it a bit better. Same thing's going to happen. And then you hit shift here, shift, that's like my second button, shift ABC, and it will change it automatically to 3 over 2. So whichever calculator you're using. That's how that's going to work. Okay. So anyway, that turns into 3 over 2. So the 24 is now a 3, and the 16 is now a 2. Next, let's deal with the a's. We have a squared and a to the 4th. Again, you subtract where the larger number is at. So since the larger number is on bottom, we're subtracting on the bottom of the fraction. So this becomes 4 minus 2. And now the a squared is gone on the top. And then the same thing is going to happen with the b's since the numbers are the same. We have 2 on top, 4 on bottom. We'll subtract 2 on bottom, and the 2 on top are gone. On the top, the only thing left is that 3. So I'm going to put that 3 on top. On the bottom, first we have that 2. And again, make sure you're keeping your work neat. This is where it could get messy. A, this is a to the 4 minus 2. So this just becomes a squared. And then we have b to the 4 minus 2. So this becomes b squared. And that's our final answer. Questions over number 2. All right, I'm going to kick it up a notch. We are coming back to factoring. Number 3. 3x plus 6 over x squared plus 11x plus 18. We're going to start with 2 easier factoring problems. First on top, 3x plus 6. You may not recognize that, but that is a factoring problem. I'm going to give you a couple hints here. Hint number 1. We're not going to use an ACB chart. We only have 2 terms. The no squared. Hint number 2. The way we're going to solve this, it's what you should look for every single time you have a factoring problem in front of you. Anybody know what this is? Hint number 3, it is 3 letters. Nope. 3 letters. The name of this method. GCF, yes. Thank you, thank you. GCF. Every time you have factoring, look for the GCF. Most of the time there won't be one, but when there is one, if you don't pull it out, obviously it's going to be wrong. 3x and 6, what do they both have in common? What is it? Not 2. 3. 3. GCF is 3. Always look for a GCF. So let's take the GCF out. When you do this, we're going to divide both terms separately by that GCF. Reminder, the GCF does not disappear. It just comes out of the expression. So I'm going to bring that 3 down and put it outside a set of parentheses. And then what's left over after the division, that's what I put in the parentheses. 3 over 3, those will cancel, and I'll have x plus 6 divided by 3 is 2. So in the original problem up here, on the top it was 3x plus 6. Now I know it's actually 3 times x plus 2. So I'll replace it. And now we have to do the bottom problem. X squared plus 11x plus 18. This should be more familiar. We've done these recently. Before I start, again, we always ask, is there a GCF? This one does not have a GCF, and there's a very obvious, like, dead giveaway. Yes. Ooh, there's prime numbers. Yes, that's one way. Even more obvious than that one, though. That is true, though. What's another reason we can look at this and automatically we know there's no GCF. Yeah? Not the exponent. What's the first number? 1. If any of your numbers are 1, automatically no GCF because we will never pull out a 1. Pulling out a 1 does nothing. So, if you see that that first x squared has nothing on it, no GCF will go immediately into the ACB chart. So let's label ABC. Set up our ACB chart. Couple points of discussion because this did appear on the last test and I saw a lot of common mistakes. Number 1, the left side of the chart is A times C. I had some students doing A plus C. It's A times C. And then it's B on the right side. I also had some students that flipped the columns completely and then they got wrong numbers, obviously. A times C, 1 times 18, that's 18. And that 18 is positive. B is in the middle, it's 11. Since 18 is positive, we're adding to get that 11. So we're multiplying on the left and adding on the right, the numbers that we find. That's what we're doing with them. Let's find those numbers. 18 has 3 pairs of factors. 1 and 18. If I add these, I'll get 19, not 11. So let's keep going. 2 and 9. I'm going to stop there. 2 plus 9 equals 11, and that's exactly what I'm wanting. So these are the correct numbers. And they're both going to be positive. So let's set up our factors here. X is in the front. And then, again, both positive. So this is plus 2 and plus 9. So just like with the first problem, I'm going to replace the bottom with x plus 2, x plus 9. I want to keep this looking nice, so I'm going to write it again before I make any changes. 3 times x plus 2. X plus 2 times x plus 9. One more step and then I'm done. There is something I can cancel here. Does anyone see what it is? The x plus 2s. We have x plus 2 on top and x plus 2 on bottom. If you have that set up, the same thing, top and bottom, you can cancel. So I'm going to put a strike through both of those. Whatever's left, that's my answer. 3 over x plus 9, keep that in parentheses, please. There you have it. This concept here, the factoring and the canceling, that's the biggest thing on this whole test. You're going to do that on almost every single problem. So once you get that idea down, you're ready. You're going to be set. I want to go back to the point about the parentheses. Please put parentheses even if it's just one term, because I'll have students who will go, oh, 3 and 9, I can simplify that. No, you can't cancel those because the 9 is part of an expression, the 3 is not. So use parentheses and you won't make that mistake. And by the way, those of you planning to go to pre-cal, that is a common mistake I still see in my pre-cal students. Don't pick up the bad habits now because then they stick later. Questions on number 3 before we do number 4? Okay. We're just going to keep factoring and canceling on these next several problems with different types of factoring. X squared minus 4x minus 21. X squared plus 7x plus 12. Those are both factoring problems. X squared minus 4x minus 21. Is there a GCF? Always check for that. Is there a GCF? Yes or no? No. Again, should be obvious. The front number is 1. If that's the case, no GCF. Move along. Trinomial, 3 terms. A, B, and C. So we're going to set up our ACB chart. A times C on the left and B on the right. A times C, 1 times negative 21, negative 21. Since it's negative, we're going to subtract on the right side. B in the middle is negative 4. 21 only has 2 pairs of factors. 1 and 21, if I subtract these, I will get 20. It's not even close. The other pair are 3 and 7. When you have subtraction, I want you to write it out both ways. I had several students on the last test, there was a problem just like this where there was subtraction, and they had the right numbers, but they put this negative on the wrong number. Obviously that's incorrect. You're going to lose some credit. So let's write it out both ways to make sure we choose the correct one. The two ways are 3 minus 7 and 7 minus 3. 3 minus 7 is negative 4. 7 minus 3 is positive 4. And we want negative 4 in this problem, so we're going to go with 3 and negative 7. So those are going to be our two factors. We have our x's, positive 3, so plus 3, negative 7, so minus 7. Let's go ahead and replace that. It goes on top of the fraction, x plus 3, x minus 7. And we'll do that again with the bottom. X squared plus 7x plus 12. Once again, the first number is 1, so no GCF. We'll go straight into the ACB chart. Label A, B, C. And then our ACB chart is A times C on the left, B on the right. A times C, 1 times 12, that's positive 12. Since it's positive, we're going to be adding on the right side. And B is 7. 12 has 3 pairs of factors. 1 and 12, if I add that, I'll get 13. 2 and 6, if I add that, I'll get 8. 3 and 4, if I add those, I will get 7. 3 plus 4 equals 7. That's what I'm looking for. Setting up my factors here. X's go in front. Both positive, so plus 3, plus 4. And that will go on the bottom of my fraction. X plus 3, x plus 4. Now that we've factored, we can go into the canceling step. Again, I want a nice version first, so I'm going to write it again before I cancel. X plus 3, x minus 7, over x plus 3, x plus 4. Hopefully you notice the x plus 3 on top and bottom. We can cancel those out. So we have x minus 7 over x plus 4. That's our answer. Once you've got that down, go ahead and flip it on over. Still have a couple more factoring problems to get to, some new types, and then a couple of repeats. Number 5, this one's going to be important. X minus 4 over x squared minus 16. X minus 4, there is absolutely nothing I can do with that. The only thing I would change is I would put parentheses around it. So again, I like parentheses around my expressions. It avoids mistakes. X squared minus 16. That is a factoring problem. Let's talk about it. There are 2 ways to approach this problem. Most of you are going to pick the first way I'm going to show, and then a few of you will pick the second way because you'll notice it. And it is an easier way, but you have to notice it. If you don't see it that way, you're not going to use it. So let's talk about the most common way to approach this problem. We have a 1 in front here. No GCF. We have x squared and then 16. Don't have anything in common. We can solve this with an ACV chart. We can. Even though it's only 2 terms, it's doable. A times C and then B. I am missing one term. Which one is it? A, B, or C? B. I'm missing B. A has the x squared, and then C at the end has no x on it. So the middle term with the x, the B term, it's missing. Since the B term is missing, what number is it? 0. So one way you can do this, if it helps, you can write this out as x squared plus 0x minus 16. You don't have to, but if that helps you, you're welcome to do so. But yes, it's not there, it's 0. So B is 0. And then A times C, 1 times negative 16, that's negative 16. And since it's negative, this problem, we're subtracting those numbers. (16) has 3 pairs of factors. 1 and 16. If I subtract those, I'll get 15. 2 and 8. If I subtract, I'll get 6. And the last pair, 4 and 4. 4 minus 4 is absolutely 0. That's what we're wanting. So we need 2 4s. One of them is positive and the other is negative. So 4 and negative 4 are the factors. Setting up my factors, x's go in the front. We have a plus 4 and a minus 4. Now I'm going to show you the other way. You can also see it as a shortcut because it very much is a shortcut. I'm going to write out the problem again. And I'm leaving space because this problem has a name, and I'll write it above it. We do teach this. You at least saw it in Algebra 1, and then depending on which teacher you had last semester, you might not have been shown it again, but if you had me, I showed this to you last semester. X squared minus 16, it is its own category of problem. And your hint is, the name is 3 words. Does anyone remember what this problem is called? What is it?
I was going to say perfect square.
You're on the right track. The 3rd word is square, so I'll give you that. Yeah?
Root.
Nope. That's how I'm going to solve it, with a square root.
The 3rd word is square root?
The 3rd word is squares. Let me write it out. Kind of makes like a hangman type of thing. Anyone remember?
No. It's
W.
Nope. Do you remember the technical term for subtraction? Another word for subtraction, not minus.
Difference.
Difference. Thank you. Difference of squares. That is the name of that kind of problem. The proper way is that's actually a difference of squares. And to factor it, if you notice it's a difference of squares, all you have to do is take the square root. So we square root the front, square root the x squared, square root the back. Do not put the negative in there with it. We do not square root negatives. We know that. Doesn't work. When you square root the front, we make two factors here, two factors to make it work. Square root of x squared is just x, so we put 1 in the front of each of them. Square root of 16, I hope you know that's 4. So we have 4 at the back of both of them. And then you need to have a 1 of each. Remember that plus or minus kind of thing? When you take a square root, it's exactly what I'm talking about. You have a plus in one of them and a minus in the other. That's how it factors. It's much faster, but you have to notice it in order to use it. Now, here's the thing. I anticipate that most of you will use the first method on the test, which is fine. No problem with that. But if you plan to go to pre-cal, if your goal is to study math at a higher level, I am pushing you to do the difference of squares method because there are much harder versions of these problems. You won't see them in here, but you will see them in your higher level math classes, and trying to do it the other way is going to be a bit of a pain, to put it lightly. So get used to the difference of squares. It's just going to make you a better math student. That's my recommendation there. You are welcome to use whatever on the test. Just wanted to give you that heads up about that. Okay, let's finish this problem. Now we know what x squared minus 16 is. It's x plus 4, x minus 4. And let me write that out again nicely before I mark it up. X minus 4 over x plus 4, x minus 4. Hopefully you see the x minus 4 on top and bottom. We can cancel those. Now here's the thing, common mistake I see is writing the answer from here. We only have x plus 4 left, but it's on the bottom of the fraction. So if I just write x plus 4 as my answer, that is not going to be correct. Since it's on the bottom of a fraction, it stays in that fraction. So it'll stay on the bottom, x plus 4. That looks a bit odd. What should I put on the top there? Can't have a fraction without something in it on the top. A 1. This is where the 1s come into place. So when we cancel, these become 1s, but more specifically, I'm concerned about the top one. Cancels, all you have left is 1. So that 1 needs to go in the top of your fraction. At this point, it is just a placeholder to hold a spot. Questions on number 5? We got 2 more. I'll try to get through these a bit quicker since these are all a review of what we've covered already at this point. Number 6, 2x squared plus x minus 3 over x squared minus 11x plus 10. We've got 2 factoring to do. So let's start with the first one. 2x squared plus x minus 3. There's a 2 in front, so there might be a GCF here. Is there a GCF? Got a mixture of answers. There is not a GCF. Can someone tell me like the dead giveaway why there's not a GCF? There's a 1. V is 1. If one of your numbers is 1, no GCF. So now we'll go straight into slide and divide, A, B, and C. This problem's different. We have a number in A's spot, and remember, that makes it a little more complicated. There's an extra step. This is slide and divide. And I showed you this in the last unit as like a trick. So I set up my factors, I put the x's in the front like always. And then reminder, slide and divide means once I figure out whatever these two numbers are, I'm going to divide both of them by that a, the 2. So I'm going to go ahead and set that up now. That way I won't forget it later. So whatever this number is, I'm going to divide it by 2. And whatever this number is, I'm going to divide it by 2. Just going to put that in place now. Now I'm going to go back. I'm going to figure out the factors with my ACB charts, and then we'll slide and divide. ACB, A times C. 2 times -3, that's -6. Since it's negative, we're subtracting on this problem. And then B is 1. It's positive 1. Anytime your AC is a 6, I want you to write out both pairs of factors. Because if that B is a 5, it could be 1 and 6 or 2 and 3. And that problem catches a lot of students off guard. So it's just a pro tip from me. 6, we have 1 and 6, 2 and 3. If I subtract 1 and 6, I'll get 5. So clearly I'm going to use 2 and 3. Again, when it's subtraction, I want to see both ways, go both ways. 2 minus 3, 3 minus 2. 2 minus 3 is -1. 3 minus 2 is positive 1. I want positive 1 for my problem. So I'm going to go with this version, 3 and -2. The negative goes on the 2, not the 3. Now I can fill these in. X minus 2, x plus 3. Next I'll do slide and divide, which I've already set up, so I wouldn't forget it at this step. 2 over 2, that divides nicely, so I can just divide it. X minus 1. 2 divided by 2 is 1. 3 divided by 2 is not nice. It's a decimal, 1.5. So I'm going to slide that 2 in front of this x, and now we have 2x plus 3. That is how the top of the fraction factors. The -6. So that's A times C, and my A is 2, my C is -3. So 2 times -3 give me -6. Yeah? Okay, so let's fill that in. On the top of the fraction, I now have x minus 1. 2x plus 3. Now let's figure out what the bottom of the fraction is. And that problem is going to be quicker. X squared minus 11x plus 10. A is 1 here, no GCF, ACB chart. Label ABC. And let's set up our ACB chart. It's A times C on the left and B on the right. A times C, 1 times 10, that's just 10. And it's a positive 10. So in this problem, we're going to add on the right side. B is -11. 10 has 2 pairs of factors. Let's start with 1 and 10. And luckily for us, 1 plus 10 is 11, but I want -11. How do I make that happen? How do I make -11 instead of +11? Yeah?
Both numbers are negative.
Both negative. -1 plus -10 is -11. So if you're adding and you end up with a negative number, it's all negative. So my factors are -1, -10. Let's set it up. We have our x's in the front. We have -1 and -10. And now I'll replace that up in the original problem. X minus 1, x minus 10. I'm going to write it once more before I mark it up. X minus 1, 2x plus 3. X minus 1, x minus 10. X minus 1 on the top and bottom, those will cancel each other out. And the leftovers, that's our answer. 2x plus 3 in parentheses over x minus 10. Questions over number 6 before we get into our last problem. Okay. Number 7, x squared minus 64 over x to the 4th plus 4x cubed minus 32x squared. Let's start with the x squared minus 64. This is just like number 5, where you have the two ways to do it. You have the factoring way like normal, or the ACB chart, I mean to say, or the difference of squares, which is the shortcut, whichever one you notice. So when you get a problem like this in front of you, you're going to use whatever method comes to mind. So if that's difference of squares, I would use that. If it's not difference of squares, then it's going to be the ACB chart. Now again, I predict that most of you will prefer the ACB chart method on the test, so that's what I'm going to use here. So we have 1 in front, so we have A and C. And again, if it helps, I'll rewrite it with B as 0. We have x squared plus 0x minus 64. We have A, B, C. Now we can see the B, it's a 0. For our ACB chart, we have A times C on the left and B on the right. A times C, 1 times negative 64, that's negative 64. And since it's negative, we're subtracting on this problem. I'm not going to write out all the factors for 64 because that'd be a bit painful. So could someone give me the correct two numbers? Just the numbers, don't give me the signs yet. 8 and 8. 8 times 8 is 64. And I didn't even fill in the 0 yet. Hang on. B is 0. That would have helped to know. We're trying to get 0. And then 8 minus 8 is 0. So just give one of those 8s a negative. And those are our factors. We have x plus 8 and x minus 8. That's how the top factors. I'll go ahead and fill that in. X plus 8, x minus 8 on top of the fraction. The bottom's going to take us a moment. We have x to the 4th plus 4x cubed minus 32x squared. What do we always look for first? GCF. On the surface, there does not appear to be a GCF because the front number is 1. So we're looking at the wrong thing. There is a GCF here. What is it? What do they all have in common?
2x.
X squared. But I see what you're getting at there. Yes, they each have 2 x's. We have x to the 4th, x cubed, x squared. They all have x's. And you're going to take out the lowest amount of x's that are there. That would be the x squared. So our GCF is x squared. And we pull out the lowest number of x's because that's how many we could take out of all 3 of them. If I tried to take out 3 from x squared, I can't do that. It doesn't have 3 to give me, it only has 2. So whatever the lowest one is, you're going to take that out of all of them. Make sure you pay attention and look for this. I will have students that will completely ignore the fact that the exponents are higher than they should be, ignore that they all have x's, and they'll just do ABC and get an answer. They'll be missing the GCF. That's the problem. So make sure you look for it first. Don't forget, GCF comes out. It doesn't just disappear. We got to take it out and put it on the outside. Going through each of these, I am dividing, so subtract the exponents. We have 4 minus 2. This is x squared. Plus 4, 3 minus 2, that's just 1, so x. Minus 32, and we have x squared on the top and bottom, so that's just going to cancel completely. This is what we currently have. Now don't just do one thing and assume you're done. Inside those parentheses, x squared plus 4x minus 32 is another factoring problem. Here we have the trinomial. So I'm going to do the ACB chart with this. Front numbers 1, we have ABC. I'm going to set up my table, A times C and B. And A times C, 1 times negative 32, that's negative 32. Since it's negative, we'll subtract on this problem. And B is positive 4. Once again, 32 has quite a list of factors. I would like to not do that. Give me the right 2 numbers, please. 8 and 4. Subtraction, show both ways. Make sure you're putting the negative on the correct number. So we have 4 minus 8 and 8 minus 4, and I want positive 4. 4 minus 8 is negative 4. 8 minus 4 is positive 4. That's the one I want. So the negative goes on the 4. Setting up my answer here, this x squared is still in my answer. So I'm going to bring it down. It's just going to hang out in the answer space. It's not going to bother anyone. And then setting up my factors, we have our x's in the front. Then we have minus 4 plus 8. So that whole thing is going to go on the bottom of my fraction in the original problem. X squared times x minus 4 times x plus 8. And I'm going to write it up again before I start canceling things out. X plus 8, x minus 8 over x squared, x minus 4, x plus 8. Hopefully you see the x plus 8 on top and bottom. It's okay that they're not like completely over each other. That's fine. You just have to have the same thing, top and bottom, and they will cancel. So I'm going to cross both of those out. I can't cancel anything else that's left. I don't have the same thing, top and bottom. So that's my answer. Let's make it nice. X minus 8 on top, x squared times x minus 4 on the bottom.